Welcome. Today, we delve into one of the most fundamental concepts in all of biology, a process that is silently and constantly working to keep you alive and healthy, homeostasis. So, what is it? In the simplest terms, homeostasis is the body's remarkable ability to maintain a stable, relatively constant internal environment regardless of the ever-changing world outside. Think of it as a masterfully conducted symphony where countless individual processes work in perfect harmony to maintain equilibrium. It's the reason your body temperature stays right around 37 degrees Celsius or 98.6 degrees Fahrenheit, whether you're walking through a blizzard or relaxing on a sunny beach. It's the reason the sugar levels in your blood remain within a narrow, healthy range even after you enjoy a sweet dessert. This isn't a static state, but a dynamic, continuous process of adjustment. Imagine a tightrope walker constantly making tiny corrections to stay balanced on the rope. That's your body, every second of every day, making countless adjustments to temperature, pH, fluid levels, and more. This balancing act is not just a neat biological trick, it is the very foundation of our physiological function and overall health. When homeostasis is maintained, our cells, tissues, and organs can perform their jobs efficiently. When it is disrupted, it can lead to dysfunction and disease. Understanding this core principle is the first step to appreciating the incredible complexity and resilience of the human body. Now that we understand the concept of homeostasis as a balancing act, let's look closer at what exactly the body is trying to balance. There are several key variables that must be kept within a very narrow range for our cells to function properly. First and foremost is body temperature. Our enzymes, the catalysts for virtually every chemical reaction in our body, are highly sensitive to temperature. Too hot and they can denature and stop working. Too cold and their activity slows to a crawl. Homeostasis acts like a precise thermostat to keep us in that Goldilocks zone of about 37 degrees Celsius. Next is blood glucose. Glucose is the primary fuel for our cells, especially our brain. Homeostasis ensures a steady supply of this energy source, preventing the dangerous highs of hyperglycemia and the debilitating lows of hypoglycemia. Then we have the chemical environment of our internal fluids. This includes the pH balance, which must be kept slightly alkaline. Even small deviations can disrupt protein function and metabolic processes. Equally important are electrolytes such as sodium, potassium, and calcium. These charged particles are essential for nerve impulses, muscle contractions, and fluid balance. Speaking of which, the body must meticulously regulate its overall fluid volume and composition to maintain blood pressure and ensure proper cell function. Each of these variables is like a dial on a complex machine, and homeostasis is the master controller, constantly monitoring and adjusting each one to keep the entire system running smoothly and efficiently. So, how does the body actually achieve this incredible balancing act? The primary mechanism is a process called negative feedback. While the name might sound, well, negative, it's actually the key to stability. A negative feedback loop is a control system that works to oppose or reverse a change, bringing a variable back towards its ideal set point. The perfect analogy is the thermostat in your home. You set it to a comfortable 70 degrees. If the temperature rises to 72 degrees, the sensor detects this change and signals the air conditioner to turn on. The AC cools the room, counteracting the initial rise in temperature until it's back at 70 degrees, at which point the AC turns off. The response, cooling, negates the original stimulus, heating. Your body does this constantly. If you step outside on a hot day, your internal temperature begins to rise. Your nervous system, the sensor, detects this. It sends a signal to your brain, the control center, which in turn activates your sweat glands, the effectors. The evaporation of sweat from your skin cools you down, bringing your body temperature back to its normal set point. Conversely, if you're cold, you shiver. Those rapid muscle contractions generate heat, raising your body temperature. This principle of detecting a deviation and initiating a counteracting response is the workhorse of homeostasis, governing everything from blood pressure and hormone levels to oxygen concentration in your blood. While negative feedback is all about stability and returning to a baseline, the body sometimes needs to do the exact opposite. It needs to rapidly amplify a process to achieve a specific, time-sensitive goal. This is where positive feedback comes in. Unlike its counterpart, a positive feedback loop reinforces and strengthens the original stimulus, pushing the body further and further away from its normal state until a definitive endpoint is reached. It's not about maintaining balance, it's about creating a runaway, escalating effect to get a job done quickly. A classic example is blood clotting. When you get a cut, the vessel wall is damaged. Platelets in the blood adhere to the site and release chemicals. These chemicals don't stop the process, they attract even more platelets to the site. This growing mass of platelets releases more chemicals, attracting still more platelets, creating a cascade that rapidly forms a clot and seals the wound. The process only stops once the clot is formed. Another powerful example is childbirth. The pressure of the baby's head on the cervix stimulates nerve impulses to the brain. The brain triggers the pituitary gland to release the hormone oxytocin. Oxytocin travels to the uterus and causes stronger contractions, which pushes the baby's head even more forcefully against the cervix. This stimulates the release of more oxytocin, leading to even stronger contractions. This amplifying cycle continues with increasing intensity until the baby is born, which removes the initial stimulus and ends the loop. Positive feedback is a rare but powerful tool used for specific explosive events where stability needs to be temporarily abandoned for a greater purpose. We've established how homeostasis maintains stability during normal daily life. But what happens when that stability is severely disrupted by an injury, an infection, or significant stress? This is where the body's incredible self-repair mechanisms come into play. It's best to think of self-repair not as a separate system, but as homeostasis in action, a more dramatic and focused response to a significant challenge. When you cut your finger, burn your hand, or fight off a virus, the local environment is thrown into chaos. The goal of the healing process is to clean up the damage, remove any threats, and meticulously rebuild the tissue to restore its original function and, in doing so, restore homeostasis. This is a multi-layered, coordinated effort that operates at every scale. At the most microscopic level, individual cells are repairing their own DNA. At the tissue level, complex processes like inflammation and regeneration are occurring. Organs can work to mend themselves, and at the systemic level, the immune system acts as the master coordinator, directing resources and personnel to the site of the injury. So, the quiet, constant adjustments of homeostasis and the dramatic, visible process of healing are two sides of the same coin. Both are driven by the same fundamental goal: to maintain the integrity and stability of the internal environment, ensuring the long-term survival and well-being of the organism. Healing is, quite simply, the ultimate act of restoring balance. To carry out the complex task of healing, the body employs a sophisticated and diverse toolkit of repair mechanisms. Let's start at the smallest scale, the cellular level. Every day, your DNA incurs thousands of damaging events. A dedicated team of proteins is constantly proofreading and repairing this genetic code to prevent mutations. When a cell is too damaged to be repaired or becomes potentially cancerous, it can initiate a process called apoptosis, or programmed cell death. It's a noble act of self-sacrifice to protect the health of the entire organism. Another crucial process is autophagy, which literally means self-eating. This is the cell's internal recycling program, where it breaks down old or damaged components to reuse their parts and keep itself clean and efficient. Moving up to the tissue level, we have inflammation. While we often think of it as a problem, acute inflammation is the body's essential first response to injury. It's the biological equivalent of sending in the emergency services. Blood vessels dilate to bring more blood, immune cells, and nutrients to the area, creating the characteristic redness, swelling, and heat. This process walls off the injured area, fights off any invading microbes, and clears away debris, setting the stage for rebuilding. Finally, at the systemic level, the immune system acts as the project manager.
It coordinates the entire response, distinguishing between self and non-self, deploying specialized cells to fight infection and signaling the transition from the inflammatory phase to the rebuilding and remodeling phase. Together, this toolkit forms a powerful integrated system for restoration. While the body's repair toolkit is impressive, its ability to fully regenerate damaged tissue varies dramatically from one part of the body to another. There is a wide spectrum of regenerative capacity among our organs. The undisputed champion of regeneration is the liver. It has an astonishing ability to regrow. A healthy liver can regrow to its full size even after up to 70% of it has been removed. This is because its cells, called hepatocytes, can readily re-enter the cell cycle and divide to replace lost tissue. Skin is another excellent example of a highly regenerative tissue, constantly replacing itself throughout our lives. At the other end of the spectrum, we have organs with very limited regenerative capacity. The heart, for instance. When heart muscle cells die during a heart attack, they are not replaced by new muscle cells, but by non-contractile scar tissue. This permanently weakens the heart's ability to pump blood. Similarly, the brain and central nervous system have a very limited ability to regenerate neurons, which is why spinal cord injuries and neurodegenerative diseases can be so devastating. Somewhere in the middle are tissues like bone, which can heal remarkably well, and skeletal muscle, which has some capacity for repair. Underlying much of this regenerative potential is the activity of stem cells. These are undifferentiated cells that can become various specialized cell types. They act as an internal reserve, ready to be called upon to help rebuild and repair tissues throughout the body. The varying presence and activity of these stem cells is a key reason for the wide spectrum of regeneration we see. We have explored the intricate and powerful systems of homeostasis and self-repair. The final and perhaps most important piece of the puzzle is understanding that we are not just passive observers of these processes. Our daily choices and lifestyle habits have a profound and direct impact on how efficiently these systems operate. Think of it as either helping or hindering your body's natural abilities. Nutrition is paramount. It provides the fundamental building blocks, the proteins, vitamins, and minerals that your body needs to carry out repairs and maintain balance. Quality sleep is non-negotiable. It is during deep sleep that the body performs much of its most critical repair and restorative work, cleaning out metabolic waste from the brain and rebuilding tissues. Regular exercise is also crucial. It strengthens the cardiovascular system, improves metabolic control, and can even reduce chronic inflammation, essentially fine-tuning the homeostatic mechanisms. On the flip side, chronic stress is a major disruptor. It floods the body with hormones like cortisol, which over time can suppress the immune system and impair the healing process. And of course, the natural process of aging can make these systems less responsive and efficient. The empowering conclusion is this: by making conscious healthy choices, eating a balanced diet, prioritizing sleep, staying active, and managing stress, we can actively support and enhance our body's incredible innate capacity for self-regulation and healing. We can become active partners with our biology, nurturing our inner healer and promoting a lifetime of resilience and well-being.